Hi everybody, this is Mike Heumann of G2M Research and welcome to the G2M Research Multi-Vendor Webinar on will storage systems and storage networks keep pace with NVMe over fabrics. Just I'll go through the ground rules real quick, and then after that we'll have each of the sponsoring vendors do a short presentation on their products relative to this topic. Then we'll go through 3 key panel questions we'll ask. We'll also have 2 audience survey questions mixed in with that, and we'll wrap up with an audience Q&A. Just a couple items here. When you do your questions and answers, there's a Q&A window in Zoom. If you haven't used it before, please enter your questions in there, and we'll answer those questions when we hit the Q&A section, but that way they won't get forgotten. During the audience surveys, you should be able to pop up the audience survey window. Just click on the selection that you want, and just go ahead and save it. Finally, we are recording this webinar, and we will make both the recording available, which will be on YouTube, on the G2M YouTube channel, and PDF of the slide set. Those should get sent out on Thursday to everybody who is registered for the webinar. So with that, let me go ahead and get started. So let me introduce our panelists. With us today are Josh Goldenhar. Josh is VP of Product Marketing at Lightbits Labs. We also have Ilker Selby, Senior Director of Product Planning and Business Development of Samsung. And from Western Digital, we have Eric Odom, who's Senior Director of Product Management. And finally, myself, who's the Managing Partner of G2M Research. So a couple quick fast facts around NVMe over fabrics. One spelling error, there should be NVMe over fabrics. Cameron Brett from Toshiba or Kioxia always likes to remind me of that. But it was really developed as a flash-centric option or alternative to the SAS and SATA protocols that we've been using for years, all of which, of course, are based on SCSI and are really embody a lot of trade-offs around hard disk type of operation. The whole idea with NVMe over fabrics is to provide significantly faster I/O with a lot lower latency and a lot less overhead than the SCSI-based protocols. NVMe over fabrics is supported on a large number of different protocols and fabrics, including Fiber Channel, which is NVMe/FC, NVMe/TCP, which is on Ethernet using TCP as flow control, NVMe over RoCE, which is on Ethernet also, but uses RDMA over converged Ethernet flow controls, and then NVMe over InfiniBand. Now, if you look at the history of NVMe over fabrics, it was largely picked up initially by a handful of startups, and it's finally been picked up and it's supported by all the large vendors today. But if you look at the solutions for a lot of them, the performance they provide out of it oftentimes doesn't meet the capabilities of NVMe over fabrics. And there's a variety of reasons for that. Some of it's legacy and other things. One of the big issues we've seen is that when you mix non-NVMe flash devices with NVMe over fabrics protocols, you tend to get a performance hit. So some of the results of that is system performance often lags that of local flash storage, which is kind of the idea that NVMe over fabric was designed to avoid. And so what we're going to be talking about today are some alternative storage technologies and approaches that avoid these issues. All 3 of the companies we have here have a vast background in both NVMe and NVMe over fabrics, and they'll talk a little bit about what they see as solutions to avoid the problems of the network being faster than the storage from an end user standpoint. With that, I'll go ahead and pass control over to Josh Goldenhar of Lightbits Labs. Josh, it's all yours.
Okay, thanks very much, Mike, and good morning, good afternoon, good evening to everybody out there. And we'll go ahead and get started about what in the world is a Lightbit. So Lightbit Labs, where I work, is all about hyperscale storage for all. And now that's an interesting statement, but what in the world does that mean? Well, it means that there are folks out there, we all know the top 7, the top 10, call them what you will, Googles, Amazons, et cetera, that have really taken efficiency to a place of art. How to eke out every bit of efficiency, save money, go into data centers at very, very large scale. And of course, an element of this is storage. How to make storage that's very scalable. Those of you that use the cloud on Azure or Amazon Of course, you're familiar with things like EBS for storage, or Azure has multiple different offerings. But if you're doing your own private cloud and you want to have a scalable, elastic storage, how do you do that yourself without hiring tons and tons of developers? And basically, how do you do it without having a project that's just impossible to get through? And that is what you can get from Lightbits. And this is all because cloud native applications have become the new normal. If you're deploying RocksDB, Mongo, MySQL, anything that is a scalable, scale-out database, even single instance databases such as MySQL, Postgres, things like this that are being deployed under bare metal, virtual machines, containers, they all need low latency. Sometimes they need high bandwidth for startups, shutdown, backups, rebuilds, and they all benefit from consistent response time, and hence, commonly they're deployed with local flash, usually in the way of NVMe to be the highest bandwidth and lowest latency. But when you do this, when you put local flash drives into every host, even though the hosts can replicate on their own, these applications generally can do their own data protection. You get great performance, but you suffer from really long recoveries. You have now physical ties to the application servers. And overall, one of the biggest things you get is very poor local flash utilization. That is overall. You deploy a flash drive to every single host. Not every single host needs the whole drive. Not every single host needs a drive at all. So what you end up with is a lot of NVMe you've paid for that you're just simply not using. It looks sort of like this. You get racks of application servers, local flash, as we talked about. It does limit your server SKUs, which is nice. But a drive failure or a rebuild necessitates a full rebuild of that drive. So that is, in this scenario, if you have a server fail or you have a drive fail, you might be able to move your virtual instance or your containerized instance or your bare metal instance to another physical machine, but that means that drive on that physical machine is going to be empty. So it's going to do a complete rebuild over the network. If you're using 25 gigabit, depending on how busy things are, depending on how loaded your network is, this could take 6 to 8 hours. And all that time, you're going to be in degraded mode. And of course, you're open to another failure. So how do you fix this? This results in this severe flash underutilization. And this is based on interviews from customers of ours that say from a capacity standpoint, you could be as much as 80% wasted. That is, they think that overall over their fleet, they're only using about 20% of the flash they install. That means 80% of those dollars you spent is simply wasted. And from a performance standpoint, you have to think about that as well. If you put a handful of drives in a host, especially if you put something like 2, and these drives can do 600 to 800,000 IOPS each, you may have as many as 1.5 million IOPS available just on that local host, which is more than that one local host can consume. Therefore, it's wasted. If you can't use all the IOPS, then you've spent money on IOPS. It's part of the reason also you spend money on NVMe, and it's simply wasted. So how do you fix this problem? Well, I have news for you. There is a solution out there, and we call it LightOS. It's Lightbit Labs LightOS. As Mike talked about the different flavors of NVMe over Fabric, we are standards-based 100%, based on NVMe over TCP. And what we can give you is a much higher uptime, very, very short recoveries, lower TCO, and you can get as arbitrarily close to 100% utilization as you want to. You do this by sharing NVMe over TCP protocol. So instead of flash drives inside each host, you go ahead and disaggregate your flash into external storage servers. These storage servers take care of drive failures, they take care of server failures, and you get local flash performance still. So you're getting really the best of both worlds, local flash performance, but you get redundancy and other features you're used to. Some features like all flash arrays out there, such as thin provisioning, compression, and this enables you to just get much, much better value. You can use fewer SSDs, get the same performance, and tailor the environment to exactly what you need. So you're using up all your IOPS, you're using your capacity, and hence this results in much, much higher TCO. So you get increased operational efficiency. You're going to be able to scale independently. Rather than having to scale your storage and compute together, you scale them independently. It's all software defined. We are 100% software defined, so you pick the servers of your choice. We have server offerings for you if you want that as well. Standard infrastructure, standard networking. So keep in mind we're TCP/IP. That means there's no new protocol you have to learn on the wire. You don't have to find a new way to do port bonding. You don't have to implement PFC, ECN, things that RDMA environments, because they're made to be on lossless networks, and hopefully we all know that Ethernet is a lossy fabric. So therefore, why not use the thing that was developed, tens of years ago to deal with the fact that Ethernet is lossy, and that is TCP/IP. So don't learn something new, learn what you know and get absolutely fantastic performance with rich data services. So you can still get things you're used to for all flash arrays, but at much higher performance levels, going back to what Mike was talking about. Our use of software on commodity and commodity marches on, or standard servers, we get more and more cores, we get higher bandwidth. This all leads towards this being the absolute, not just least expensive solution, but highest performing. It's very low latency, very high IOPS, high bandwidth, and all of this lets you reduce TCO, maximizing your return on investment by maximizing your utilization. And the best yet, you can use QLC media. A lot of folks think you can't use QLC NAND media because you're not going to get the write endurance that you need. But because of our management, our flash management layer built into LightOS, we go ahead and we extend the life of QLC by 5 to 10 times by making sure we always write to it in large chunks and sequentially, even though your IO load might be a random write load. We go ahead and smooth that out so you get, you can use the least expensive media and still get very, very high performance. It looks like this. With application servers just loading a standards-based TCP driver. This is in the upstream kernel. There's no software from Lightbits you have to add. You guys already have this if you're using Ubuntu or SUSE or Red Hat. And you go to our servers that have LightOS installed, which is a set of packages on standard networking. And just to wrap up, going back to the core of this talk, why do you want to do this? Why does it make sense to do software-defined storage on top of commodity? And if we look at this chart, all these elements are what you mix together to do software-defined storage. You have Ethernet, you have PCIe for the NVMe drives themselves, you have the performance of a single drive, and then you have the cores per socket in the CPU that is doing the actual processing of the IO. And if you look at these, everything is marching on basically together. I'm calling 100 gigabit the technology already of yesterday because there's 200 gigabit out today. I know there's at least one vendor on this call who's already announced PCIe Gen 4 drives. And those drives are going to have just tremendous possible bandwidth. You can see that at over 30 gigabytes per second. It's just monstrous if you could do, on PCIe, if you did 4 drives, you get just amazing amount of bandwidth. And on cores, we've seen the wars kind of going on between Intel and AMD, but there's other folks out there on ARM who have recently announced 80 core processors. So 80 core processors are available today. And you may think that Moore's law, as far as the density, might be running out for the processes of today. And I might agree with you. But there's been advancements in silicon photonics, things like this, that I think the number of cores of the processing power is going to keep going. And if you look at this chart, you can see these things are kind of moving together. Whereas proprietary arrays, ones that Mike alluded to, get stuck in the past because they have to design proprietary hardware, they have to maintain that, and to get their return on investment, they have to keep it alive for a while. Whereas with standard servers, with standard NVMe drives, and processors moving on, you see all these things will move in lockstep together, and software is what enables you to really take advantage of those advancements. So I do think NVMe over Fabric is going to keep advancing due to advancements in the underlying hardware, and of course with the right software such as Lightbit Labs, LightOS, you can go ahead and take advantage of that. And with that, I am done. Thank you very much, Mike.
Thank you, Josh. Let me pass control now to Ilker Selby from Samsung. Go ahead. You guys should have control now.
Thanks, Mike. Good morning, everybody. I am Ilker Selby from Samsung, and I'm going to talk about NVMe-oF fabrics today. Thanks for joining me. With that said,
I've always found, oh, there you go.
Oh,
you got it.
It went to wash. Why disaggregation? So we have been talking about the disaggregated storage and the converged storage. And as most of you know, the disaggregated storage since the introduction of storage area networks has been around more than 20 years. What has been used in the data centers and the hyperscalers, where you have the converged compute and storage environments, where you scale the compute and storage linearly and manage the resources within the same box. The part of the problem is the resources are underutilized, and you're utilizing the same storage and compute on the same network. When we move into this disaggregated storage, where you can scale the storage independently, share resources, improve utilization, and as well as manage the centralized storage services. The part of the issue is this requires efficient storage protocols and latency improvements. This is where the NVMe-oF fabric comes in, and with the introduction of the NVMe-oF fabric, this is why it's been introduced, especially with the NVMe spec came to life 5-6 years ago, and with the startups showcasing their hyperconverged solution, which is the most common. Since then, we've seen the new deployments on disaggregated NVMe JBOFs in traditional storage OEMs and vendors, and recently we see more direct attached JBOF as a SAS replacements. All these are I would say, the most common use cases, but there are other use cases that I'm not showing here. And speaking of that, is going forward, you're looking at the standard NVMe JBOF, which is based on a CPU architecture where you attach a PCI switch for fan-out. And a lot of cases in a high availability systems, you have a redundant PCI switches and attached to NVMe drives. When you look at the traditional platforms in the last few years, you see the NVMe bandwidth is roughly gigabytes to 2 gigabytes range. You have a balance bandwidth between the I/O and NVMe drives, where you have networking adapters attached to the system, roughly with the dual 100 gig network adapters. We see the bandwidth between the NVMe performance and out-of-the-box bandwidth is balanced. But going forward, what do we see? So as most of you know, that's been introduced, Gen 4 NVMe SSDs, and even the future Gen 5, PCI Gen 5, the bandwidth of these drives push into 4 to 8 gigabytes per second. So the bandwidth in the whole system, whether you're using U.224 NVMe drives chassis, we're looking at the 80 to 100 gigabytes per second, even pushing the limits to 150 gigabytes per second. So we think that network links will be the throttling the storage throughput performance, because even when you put multiple 100 gig ports, networking adapters, and even going to the 200 gig will be the limiter. Just to showcase how this looks like, as today you can put 100 gig network adapters, it barely matches the bandwidth of the NVMe drives. In the future, even you put the 200 gig networking adapters, you're roughly in a half of the bandwidth of the NVMe drives in a chassis. So this is one of the key issues. The CPU and I/O bottleneck is limiting the storage throughput performance. So what are we, Samsung, what are we looking at? So as I said, standard NVMe JBOF is being limited by the CPU and memory bandwidth to support the NVMe subsystem, as well as the PCIe limitations and network limitations. And on the top of that is, as the core counts increase, the speeds of the signal integrity complications, the system gets more complex, and it becomes a high CPU PCI complex, being the system TCO and the cost increase. And moving forward, what we've been looking at is there's a concept is Ethernet attached SSDs. By deploying, instead of using the PCIe infrastructure, utilizing the Ethernet and attaching the Ethernet switch, you unleash the scalability and flexibility on the performance, even with the standard Ethernet switches, somewhere around 3 to 4 terabits per second, you can manage the performance and the bandwidth and throughput performance. One of the caveats is you got to move the storage services, and this way the central storage services can be managed by the host servers. By doing this, you not only improve the performance, also reduce the cost and TCO. Thank you, everybody.
Perfect. Thank you, Ilker. And last but not least, we have Eric Autumn. Eric is from Western Digital. Let me get you on the right screen here and let you get started.
Great.
All right, Eric, you should have control.
Great. Thank you. And I did just want to, for those of you who aren't familiar with Western Digital, I think most people think of us when they think of hard drives and SSDs, and certainly we make truckloads and truckloads of that stuff, but we also have a platforms group that I'm part of. And so, let's see if we can click forward here. All right, so they overshot. So I want to talk a little bit about the problem we're trying to solve. I think the previous speakers really drilled into the architecture, and we all agree that Ethernet is going to be the future, and disaggregation is a very important thing. But let's jump into it from a little different perspective. I think everybody's seen the massive shift moving to the public cloud, and for on-premises computing, you really need to think differently. You need to think about creating a cloud yourself. And certainly the rate of change is something that's very, very important too. To me, NVMe-oF is not just about performance. It's about flexibility. Your ability to compose and recompose your infrastructure to keep up with business demands is really, really important. And you look at all these different things that are going on here, just the amount of change in today's economy, it's not just about performance. It's about flexibility. I'd actually put them on peer levels. And you just look at the tumult going through the economy today, being able to be flexible, to be responsive, to adapt to change quickly is really important. And I think that's a key element for NVMe-oF. Traditional IT is set up as silos, and it's mostly for control. And it covers a lot of different applications very effectively, but it's not very flexible. And as I'm concerned about that, looking forward, going into the future. NVMe-oF provides that kind of capability. And actually, this is maybe overly simplistic here. We might have a couple of different meshes. I think NVMe becomes the foundation of the new data fabric going forward. I think CXL and for the memory fabric and compute is still going to be out there, but for the data fabric, I think NVMe-oF is going to be the clear winner here. And just in terms of adoption, you see NVMe drives and arrays, and they've been around for years. I think we're just getting started now on NVMe-oF, and I think this is a really important time for people to think about their tech refresh cycles and think about what they're doing. How can I be not just fast, but flexible? How do I bring that capability to my end users and to get things done? And so NVMe-oF, I think, is the right tool. And Western Digital, we have a product that encapsulates this called OpenFlex. And OpenFlex is built on NVMe-oF, of course. It's got some fantastic performance, but it's also got this great flexibility. You see, I've got 10 slots here. I can mix and match different kinds of capabilities in this. And we also have controllers. So we sell controllers. So NVMe-oF controllers, if you want to build your own from the ground up. You may have seen that we acquired a company called Chasm, so this is now part of Western Digital. So if you want to build your NVMe-oF from the ground up, you can do that also. The other thing that we're focused on is open. And being open for us means bringing in different companies to test against this open standard. And so we've published our open composable ABI. We also have open hardware standard. So you saw the different bays that go in there. So that has been published as well. And so we already have this lab up and going, and people are coming in and they're testing their products with our NVMe-oF OpenFlex. But this is really a different approach. It's not just getting all your pieces from one company. It's really having an open architecture that allows other companies to participate in this. Because we really think NVMe-oF is really going to be the wave of the future for the next generation of data fabric. And of course, we've got the product line here. I've been talking about the parts on the right, but I think most of people, when they look at Western Digital UltraStar platforms, they're looking at our JBODs, JBOFs, storage servers. We've got transportable data, so we've got a lot of different ways to help serve our customers as far as that goes. So I think there's some additional resources. So at your leisure, you can go and take a look at that. So Mike, I'll turn it back to you.
Excellent. Thank you very much, Eric. All right, let's go to the first panel question we want to ask the panel. We'll go for Josh at Lightbits and then Elker, and then finish up with Eric. And that is, what do you believe that storage array vendors, or why do you believe that storage array vendors have been so slow to fully embrace NVMe over Fabrics? I'll let you go ahead and start, Josh.
Thanks, Mike. Actually, I think this one's pretty easy. I'd almost kind of reverse it. NVMe over Fabrics, I believe, has actually been adopted in some ways faster than other protocols. But vendors, and especially when we say vendors, and on your very first slide, you highlighted a lot of vendors that were traditional, that is with proprietary arrays and whatnot. They have systems that maybe can't support a new protocol. So they have to design a new one. If they have designed their systems so that it could add an additional protocol, they have much, much longer testing cycles. And lastly, these folks are just simply very conservative and very slow to move. They want to see the market move first, and they want to see adoption come before they add it. So you kind of set up a chicken and egg problem. Say, well, we don't need to add NVMe over Fabric because there's not a lot of adoption out there. And of course, adopters say, well, we don't know if we want to move to NVMe over Fabric because there's not a lot of storage providers out there. And that leaves little guys like Lightbits and like Kazan that was just mentioned being picked up by Western Digital. Samsung, of course, is no small player. But it's just simply that you have to wait until there's enough momentum in the industry for this to get picked up. And we are seeing it now. We saw NVMe over Fabric, that is with RDMA, picked up by players as large as Pure Storage, by players as big as NetApp on their EF series. So now we're just waiting for them to get to see the light and pick up TCP. And that's simply because releases like Red Hat have waited. They have a NVMe over Fabric in their earlier products for NVMe over TCP. You know, they're out in the very latest versions of Ubuntu, Red Hat, SUSE, but not all customers move to the latest and greatest Linux distributions. So all of this is simply a waiting game, people not wanting to be the very first, but definitely think that this year is the one to dip your toe in the water, and next year we're going to see really big pickup in NVMe over Fabric, especially for NVMe over TCP.
Excellent. Yeah, I guess it's for all of us on the front line, it's hard to remember sometimes how conservative our industry is. Ilker, what do you guys see at Samsung? Obviously, you sell to a lot of the large array vendors and a lot of other people for that matter. How do you see things going?
Well, I concur with Josh, and there are two. I believe there are two main factors. Obviously, NVMe is being very successful. We are selling a lot of NVMe drives to hyperscalers as well as the storage vendors. There are two main factors that I see compared to established iSCSI and Fiber Channel that has been around, 20 years, and established in terms of the not just from conservative storage vendor approach as well as the architecturally and specification-wise management framework is been around many years. So when NVMe over Fabric introduced, it was a protocol to address the bandwidth and latency, and where iSCSI lacked some of that elements. So if you look at the spec evaluation, we're just looking at the NVMe-MI over NVMe fabric just recently talked in the standards organizations and SNIA tweaks, and even recently there's a new tweak that's been started for IP discovery to how to manage the NVMe fabric type of management schemes. And the other part is being challenged is because it's a new fabric, interoperability between the vendors, networking vendors, as well as the different storage solution is being problematic, and that's been industry leaders are putting efforts across the board, putting standardization around NVMe fabric compatibility tests. I would say we will see these being resolved in the next year or so. Then we will see an uptick on usage on the NVMe fabric-based platforms across the board.
Excellent. And Eric, you guys are obviously very active in NVMe and NVMe over fabrics. What do you think? Are we just around the corner from this really taking off?
Well, I think it's really a couple things. Dirkler pointed out the compatibility testing, and the University of New Hampshire has done a great job for the baseline. As I'd mentioned earlier, we've got a compatibility lab that kind of goes that next level up for a true open compatibility infrastructure. But there's no question that the next generation of data fabrics is NVMe-oF. The challenge is there's going to be some disruption, and we saw the same thing with the adoptions of SAN. Companies have millions of dollars tied up in the current infrastructure. Making a graceful pivot to a new technology is not a trivial event, right? So it takes some planning, it takes some thought. I think the technology is getting there. The compatibility labs will make sure that's very smooth, and so I think you're going to take it a bite at a time. So next month we'll be publishing a case study from one of our early customers who is basically using NVMe-oF as a scale-out performance type of environment. But the true benefit of NVMe-oF goes beyond that. Like I said, the ability to compose and decompose and recompose is really, really important for business flexibility. So I think that's really going to be increasingly important. And I think eventually that's why it's going to win out. And we're already moving in that direction, right? Ethernet's already taking more of the data traffic, as you see with object storage, which is typically connected through Ethernet. So I think the momentum's all moving in the right direction.
Excellent. Let's go to the first audience survey question. I'll pop this up on the system and launch the polling. So you should see a small window that pops up, and the question is has your organization explored or deployed NVMe-oF-based storage systems and/or software yet? And it's a check one, so go ahead and answer, and we'll give you a couple minutes to do that, and then we'll move on to the next panel question. All right, we'll let the poll keep going, and I'll switch to the second panel question. We'll start out with Ilker on this one, then go to Eric, and then to Josh. And the question is, one of the big issues often thought about between NVMe-oF adapter vendors is network congestion. You know, certainly for converged networks, it's potentially more of an issue. So what can users do to avoid or mitigate its impact on application performance? And Ilker, we'll go ahead and start with you on that one.
This is a very important question when you're deploying fabric in any, whether it's a hyperscale or in data centers. The network congestion is one of our top customer concerns, especially in the large deployments. In a smaller deployments less than 10 nodes, let's say, network congestion is not major concern, a small customer base. However, when you start deploying more than 10 nodes in a data center, network congestion is becoming and how to manage it becomes a consideration. There are NVMe-oF fabric adapter vendors provides tools and methods to manage the flow control and network congestion, such as PFC, ECN, even DC-QCN. As you know, there are public papers on this area published by Azure, Microsoft, and users should deploy these techniques per their application requirements, whether it's using TCP-based networks or RDMA-based networks. Essentially, especially becomes important when you disaggregate storage and compute. Being able to manage these flow controls, it becomes important. Other considerations on this, how to validate and verify the interoperability between the network adapter vendors and the switch vendors when they're deploying. So that also impacts the application performance. So all those, I think the industry is working towards these issues, but it all depends on the end user being able to use these features and work with their favorite vendors, essentially.
Very good. Eric, obviously you guys are seeing both sides of this. What are your kind of reflections on network congestion and how to avoid it?
Yeah, well, certainly we see the same things. I mean, it's kind of endemic to Ethernet. It's so powerful and so popular. You can see how the traffic is going to get bunched up. We also focus on Rocky, and just as a reminder, Rocky is RDMA over converged Ethernet, and that converged Ethernet is the important part there. So with that priority flow control, like Ickler pointed out, it does give you a lot of tools to help manage that. Maybe create some subnets to isolate some traffic. And I think a lot of data centers are getting some experience on that in the last couple of years when with the advent of object storage and moving more data traffic over Ethernet, not just client messaging traffic. So I think there's more and more experience out there. But to another one of Ickler's points, the compatibility testing is going to be really important to make sure you're getting the most performance out of what you've got going on. And we already mentioned our compatibility lab, but again, the University of New Hampshire does some great work in that regard also.
Excellent. And Josh, obviously, you know, with your company, you focus on bringing hyperbit or hyperscale performance to lowly mortals, so to speak. I'm sure you've dealt with this side as well.
We have, and I touched on it earlier, which is both folks before me, Ilker and Eric, you're 100% right in that NVMe over Fabric can handle, that is NVMe over Fabric RDMA can be made to handle network congestion, but we have to look at why you even have to do that. And if folks listening to this remember NVMe, fiber channel over Ethernet, FCOE, fiber channel over Ethernet, how popular is that? And if you're thinking in your head, not very popular, you'd be right. And why was fiber channel over Ethernet not really adopted? Was it a good idea to have a lower per port cost? Yes. Was it a good idea to use a protocol people were kind of familiar with? Yes. Was it a good idea to put a lossless protocol on top of a lossy fabric? Maybe not. You had to do all sorts of changes. Also folks remember something called data center bridging. And then that was for individual switches. And then you needed DCBX, or data center bridging exchange, for two switches to talk to each other. Guess what all these fancy things are? They're the same things you have to enable for RDMA over Ethernet, for Rocky. It's the very same settings you have to change. So you have to learn about priority flow control. You have to learn about potentially ECN. You have to worry about what if I have switches talk to each other. So this is what actually prohibits adoption of NVMe over Fabric over RDMA for many customers we talk to. They say our network admins are not going to let us do these special settings per switch, by the way, because you have to sometimes do it on a per port basis. But guess what all these folks know how to do? They know how to control congestion on TCP networks. And that basically is the tenet here, is why not use something? TCP was developed specifically because Ethernet was not reliable, that it's lossy. And so there's already a mechanism everybody knows how to use. You can do MLAG between switches, you can do lags. If you want to aggregate multiple ports from a client to the switch, we all know how to do this. The only thing you might have to do is for a storage network, if up to you, you might want to add more bandwidth. So I think you should work on congestion control by using methods you already know.
Excellent, thank you. Let's go to audience survey question number 2, which is, do you see NVMe over Fabrics as having fundamentally changed the value proposition of storage arrays? And this is a check one. Let me launch the question. Again, we'll give you a couple of minutes to go ahead and answer that, and then we'll jump into the next panel question. All right, we'll let that go on, and let me pop down to the third panel question. And that question is, has NVMe over Fabric performance reduced the value of storage arrays relative to scale-out flash storage software, or is there still a place for storage arrays in the data center? We'll start with Eric, then followed by Josh, and then finally we'll wrap up with Ilker. So go ahead, Eric.
Thanks, Mike. I think there's going to be a place for storage arrays going forward. I think that there's still a place for a turnkey type of solution, particularly if you've got an established application, you don't see a lot of growth or change. I think that's actually not a bad fit. But I think going forward, increasingly, you're going to find more and more need for a disaggregated approach. It's going to allow you to provide that flexibility that I'd mentioned earlier. Certainly more performance is always good, but I think flexibility actually is going to be a lot of the decision key points for choosing a storage array versus a disaggregated storage. And like I say, I think the pendulum is going to be moving towards disaggregated pretty firmly. And NVMe-oF is a great fabric to make that happen, I think.
Excellent. Josh, what do you think?
I agree with Eric that storage arrays are going to be here a really long time. They're very feature rich, and a lot of folks don't necessarily need to be perfectly honest. There's folks out there that today don't have the need for storage that can be as performant as what you can get over NVMe over Fabric with the right backend. At the same time, I think a lot of arrays will be imperiled, because if you look at certain traditional arrays out there from really big vendors, I mentioned some of them earlier. I mean, Pure Storage, NetApp, IBM, they all have products that support NVMe over Fabric. But if you look at some of them, you look at the statistics of the performance they get with traditional Fiber Channel or iSCSI, and then you look at the performance they get with NVMe over Fabric, some of them are not getting any more IOPS. Some of them are hardly reduced in latency. The ones that do have lower latency, often there's a little asterisk by it, and they're only getting that really reduced latency when they're hitting their DRAM write cache. And as soon as they actually go out to media, it jumps up. Why? Because these things, these dual controller, especially arrays, were just simply not architected to handle the amount of I/O that NVMe drives and NVMe over Fabric can pump out. So there is a place for storage arrays, absolutely. They're going to be around a long time, but we believe that, like a lot of analysts, by 2025, 2026, you're going to see huge reductions in the big iron storage arrays out there, and more things are going to move to software defined.
Excellent. And Ilker, what is your opinion on this?
Well, I tend to agree with both panelists. In the same time, I think the NVMe fabric has not reduced. In fact, I think it increased the value. Part of the reason is the segregated storage arrays are gaining momentum, especially at the composable data center deployments, where you see better utilization and improvement of the networking capabilities above 25 gig, 100, even 100 gig, and 200 gig. That enables the dedicated storage networks in the data centers, large scale data centers, where the value of the disaggregated NVMe fabric, JBOFs or EBOFs solutions, we will see these solutions in the data centers, I would say, in the next 3 years. And in the storage arrays, obviously traditional storage arrays will have to adapt and provide these solutions to the, to the data centers and hyperscalers.
And that's a really good point. I think we've certainly seen a evolution of what a storage array looks like, and a lot of array vendors have certainly picked up NVMe over Fabric as a back-end fabric and to do disaggregated storage and do composable storage. So it'll be interesting to see how that goes. Maybe it's a matter of the arrays changing as much as it's a matter of arrays going away. So very good. So with that, let's go to the Q&A. We'll start with the first question. And the panelists, just to jump in as you want to answer it. The first question is, what is the Ethernet link speed to the NVMe drives? Marvel has a dual 25 gigabit Ethernet to PCI by 4 translation chip to get fully redundant 3 gigabit second of a single port of PCI 3 Gen 3 drive. So I'm curious about the Samsung approach. This sounds, Ilker, like a question aimed at you, I think.
I'm sorry, can you repeat the question? Sorry.
Yeah, the question is, it's the first one from Michael Schuett. The question is,
oh, okay.
If you go to the Q&A window, you can see it. Yeah, no worries.
Mm-hmm. Well, I think the approach is not specific implementation. You got to look at how do you balance. In my presentation, I showed the balance of the NVMe capable drives. How do you balance the I/O from the system level? So whether it's a Gen 3, Gen 4, or Gen 5, PCI Gen 5 drive, you need to balance that I/O with the capable Ethernet links. So when you're looking at dual 25 gig ports, you're roughly theoretical 6 gigabytes per second. Obviously, that could deliver the Gen 4 type of a PCI SSD. And going forward, that will double in the next generation, obviously, going to the PCI Gen 5. So the approach should be not specific to Samsung, but in general in the industry, is how do we balance the bandwidth from the NVMe SSD?
Excellent. Josh, do you or Eric have any want to add anything to this conversation on this question?
Oh yeah, I do. So it's interesting. So Michael was asking the question about the Marvell Fabrico chip, which was interesting, and I was really interested in it when it first came out. But then I thought about something that I actually call these things remote DAS. If you think about putting drives directly on the network, it is fantastic for performance, and it is fantastic, as Ilker was saying, for unleashing the performance of that. If you pair a single NVMe drive by 4 PCIe Gen 4, PCIe Gen 3 with a by 4 link, 25 gigabit is about perfectly matched. You're going to be able to, over that 25 gigabit link, get the full bandwidth of the drive. But what do you do with that? If you attach that drive to a single host you now have what I call remote DAS. You have all the limitations of DAS, and then you have all the headache of adding that over a network, and you still have no services. You know, how many people just want a drive to just be a raw drive? If I just wanted a drive to be raw, I could just put it inside the server. And the immediate reaction might be, wait a minute, but disaggregation lets you separate the two, compute and servers. And you're right, but how much value do you get out of that? If you want to add any services, like any kind of redundancy, any kind of RAID, just basic, you know, RAID protection, compression, thin provisioning, dedupe, if you want to add any of these things, the IO has to pass through a different host. And this means now you have your same bottleneck put in place. So you do get a benefit. You get a benefit of not having to add proprietary trays or separate trays. But I think that bandwidth is not worth as much as the headaches you'll get and complexity by having hundreds or thousands of individual drives that just show up on the network. You've just traded one problem for another. You're gonna have a massive management problem.
Very good point.
I think Josh
Eric, what do you guys think? Go ahead.
I think Josh brings up a really good point about the how do you manage all these devices. And in this aggregated world, you need to have some orchestration, and certainly we work with a number of different orchestration vendors, guys like DriveScale and Liquid and Caminario, and they're in our composability lab. So, you know, making sure all the pieces fit together and they do what you want to get done is important. You know, if you just want to talk about chips, certainly our NVMe-oF controller chip, it's an ASIC, so you get some really great performance out of it. You get low power, but you know, having a game plan in mind is pretty important. So the compatibility labs, I think, are going to be critical to have this this whole infrastructure get the job done for you.
All driven by the use case. Very good point. Next question we have, can you contrast latency between NVMe-oF versus some of the new technologies pooling DRAM in a similar fashion? And I'll let whoever wants to jump in on that one start.
So let me take a crack at this. I think that we've all seen how Intel has built a pretty significant following after CXL on kind of the memory fabric, you know, the CPU talking to DRAM. I think what NVMe-oF is trying to fix is a different problem. It's looking at the data fabric. So I guess I see CXL and NVMe-oF as the data fabric kind of emerging as the dominant disaggregated fabrics going forward. Josh,
Ilker, do either one of you guys want to throw an opinion on this one as well?
This is Josh. I had similar opinions. Thinking about the question immediately made me think about both CXL, which was just mentioned, but also Gen Z. And it points out that currently, if you want to pool memory, you need some kind of bus that will basically hook up a fabric and that memory as well. So today you have to go through the processor to the PCIe bus and then out the network. So that's adding a lot of issues. As far as the exact question of could NVMe over Fabric do this with a block translation layer? Yes, it could. The protocol itself is made to be lightweight, so it's probably applicable even to memory operations. By far, the biggest amount of the latency here is going to be introduced by the network fabric itself. So that's why I think that we have to get to this world that oddly goes back to old IBM technology. You know, for old IBM mainframe had CPUs and storage and memory all on the same buses. And that seems to be kind of what the world is talking about going back to. So all old things are new again. And it could work. We'll just have to wait and see what happens. But any of what we're doing could be, I think, use NVMe over Fabrics as a protocol to go over these different fabrics, because that's the whole idea.
And nothing ever changes. It just recycles in a different format. Go ahead, Ilker.
Yeah, just to add to Eric and Josh, I think we also need to look at this as an architectural change in and how you develop the systems and the software. It's not NVMe-oF Fabric is a replacement of a local pooling of the DRAM or vice versa. If think of this as like a near storage or near memory versus far storage, far memory. So NVMe-oF Fabric addresses the far storage aspect, and you could use CXL as the near storage, where you will have to re-architect your system as well as the software ecosystem.
Very, very good point. All right, next question is, with Ethernet-based SSDs, what protocol ensures reliable data delivery? Sounds like an Oker question to start out with. Yeah.
Well, when you look at not just looking in the context of Ethernet-based SSDs, you look at the Ethernet as a protocol. Security and reliability is the key. So when the deployments whether it's a TCP network or RDMA network, a lot of vendors between the switch and networking vendors, they deploy data in flight securities like IPsec or TSL security for data in flight. But also you have to think about how you deliver the security across the board from the host to the target. And industry has been working on this for a while, not just for Ethernet SSDs, but in general, the OCP security initiative, as well as other hardware root of trust developments, as well as TCG. So there are protocol, ensuring the protocol reliability and security is one of the top topics in the industry, not just for Ethernet SSDs.
Very good. All right, so let's go to the next question. Go ahead, Eric. Go ahead.
Yeah, Western Digital has a lot of different flavors of SSDs, but I'm probably not the right guy to talk about SSD level interface discussion. But you can go to our website and find out a lot more on it.
Excellent. Let's go to the next question, and I suspect, Josh, you'll probably be starting this one out. And that question is, outside of the do-it-yourself world of the Googles, Amazons, etc., adoption is accelerated by standards and the resulting multi-source interoperable solutions. How do the solutions discussed today lead us to that?
I'm rereading the question because it's so. I feel like it's kind of a leading question. It almost answers itself. Everything we've talked about today, NVMe-oF Fabrics, whether it's on Rocky or TCP, is standards-based. Interoperability labs, of course, that were mentioned, I think by Western Digital, are good to make sure that people are actually adhering to the standard. But we have those. So now the question becomes more, as you get the protocol in place, Eric touched on this, I think Ilker did as well. The management of all these resources is what's coming up. Selfishly, our product, I think, does this in that it puts a bunch of drives behind management in each server, and then with clustering technology, lets you have a really wide pool, and then lets you access that as a gigantic pool. So we're working towards that management. But there were also individual companies that were mentioned that are working on managing and provisioning lots of individual devices. So it's the solutions from Lightbits, I think, do start approaching the scalability you can get at the Googles, Amazons, and whatnot on a scale of what you'll do in private cloud in the thousands or tens of thousands of servers, and it'll just get more robust and rich over time.
Excellent.
I think one of the fun things about it.
Go ahead.
I think one of the fun things about disaggregated storage is you have at least the theoretical possibility of doing a best practices type of environment. And by that, I mean best practices for you. So we work with a number of different management companies that can suit your needs, because I don't think one size necessarily is going to fit all. So having that capability is kind of nice. At Western Digital, we certainly want to encourage that with our open compatibility lab.
Very good. And I think as it's been pointed out, all the stuff we're talking about is standards-based. So I think it's a question of often how long it takes for a standard to become, ubiquitous or become where everybody meets, and whether it's an Ethernet or fiber channel or anything else, we all go through those different things. Let me jump down to a question from Craig McCombs, and that's, does data management, data transfer, data rebuild, and redistribution all occur over Ethernet NVMe over fabrics? Do you recommend separate networks for different traffic types? I'd say that largely depends on where your hotspots are, but for those for Eric or Ilker or Josh, what do you think on that one?
I think a subnet or a subdomain is going to make sense in a lot of cases, but you really need to dial in on your configurations and what you're trying to get done, because it's a many splendored thing.
Absolutely.
This is Josh. I'd say, like so many things in life, the answer is it depends. So we actually touched on it a little earlier with Ilker and Samsung talking about drives directly on Ethernet. So if you have drives directly on Ethernet and you're doing even a simple mirror between the two, the drives are not doing that mirroring themselves. Some other host is, whether that's a target host that the I/O is going through, or if you have software RAID configured on the client, which means that you're going to go doubly over the network anytime you do a write. And in the case of a rebuild, you have to do some kind of orchestration. And if the drives can't talk directly to each other, that's going to be reading from one drive over the network to a host, and then that host relaying that information to go back to the new drive to take its mirroring place. So all that is going to occur. The answer to the question here would be yes, that kind of traffic would all be over the network. Whether the protocol would be NVMe over Fabric, I would think it should be, but that would happen over the network. The Lightbits approach is different, which is to put the drives in a host, and we have Elastic RAID, which guards against a drive failure. So in the case of a drive failure with our NVMe over Fabric or NVMe over TCP solution, you're not going to see a drive failure, and that drive rebuild is not going to happen on the network. It's going to happen within the box itself. So there are trade-offs there. The justified trade-off being what Ilker had brought up is that generally out of a box, you're going to be limited by the network bandwidth for the total number of drives you're going to put in it. So the rebuilds are not going to happen over the network, but you may have fewer drives in that one chassis unless you can get the networking up. So everything's about trade-offs. And today, if you have a completely separate storage network for iSCSI, or of course, obviously if you have fiber channel, you have a different fabric, you may want a separate fabric. We have a lot of customers that have their data at 10 gig E is fine. And so they're thinking that if they make the move to 25 gigabit, they'll have enough bandwidth to converge storage and data traffic on the same network. So they're going to go ahead and do that on the same network. Your mileage may vary, and it depends.
Excellent. Eric, do you want to jump in on this one, or Ilker?
I think I did mention it. I think subnets are probably going to be the pragmatic way to get things done on this. I'm not as articulate as Josh, I'm afraid.
Yeah, it is a good question. How to experiment. I think for software development perspective, I think this is one can imagine if putting together one host server and target drive in a single drive, you can start experimenting with the standard networking adapter cards, whether it's using RDMA or TCP. That will be my recommendation.
Good deal. And let's go to a question from Rob Davis, and this is for Josh. If Rocky is so unusable, why do many hyperscalers deploy it at tremendous scale?
Rob, my friend, Rocky is very, very good at being very low latency. Folks on this call know that I came from a different company that was all Rocky based, and you can get the lowest levels of latency out of that, but it's finicky. And the reason that hyperscalers can do it is kind of the same reason that you can turn it around and say to a general enterprise data center, hey, how come you don't just do what the hyperscalers do? That is, instead of having server racks where you have different size servers for different loads, where you have storage servers and regular servers, why don't you just do what the hyperscalers do? Just deploy a rack that has exactly the same server and exactly the same config, and then have a network team that deploys the exact same config on every switch. The answer you're going to get is mere mortals can't do that. There was a finance customer in New York we were talking to that said, if you have one application or a handful of applications, you can tailor your hardware and network environment specifically to those applications. But we have 6,000 legacy applications. This was a big bank. And so we have 6,000. If we start moving one of those applications a week to this new architecture, we still won't be done in our lifetimes. And that's basically the answer. Rocky can be made if you can be ubiquitous, if you can ensure a very standardized environment, you can make your settings very rigorous, and you don't have a lot of different generalized applications, you can make Rocky work. Also, if you need that cutting edge performance, that absolute bleeding edge, you can make that work. But for everybody else, 5 million IOPS out of a box is plenty. And 120, 140 microseconds of read latency is so far and away better than they get with anything else, that being able to do that on top of TCP is a huge advantage. And lastly, Rocky needs additional drivers in that Mellanox provides a special custom build of OFED that they recommend everybody run. OFED is dependent on the kernel. Whereas NVMe over TCP comes built into the kernel. If you get a new kernel, you get the new drivers. You don't have to update the OFED drivers and things like this. So it's just simply a lot easier. Big hyperscalers have the staff, have the specialists to do that. And NVMe over TCP, we believe, will be much more accepted, especially as its performance approaches the same levels as NVMe over RDMA.
Very good. Well, I think that's all the questions. Just as a reminder to everybody in the audience out there, we are recording this, and roughly on Thursday, we should be sending you a link to the recording, as well as a link to where you can download the slide set. Thanks again for joining. Thank you, Josh and Eric and Ilker, for sponsoring this webinar, and we look forward to talking to all of you next time. Thanks again.
Thank you.